Alright, let's solve the Leetcode problem. So the Leetcode problem is 2211. So we have to count the collision on the roads. We are given the n cars on an infinitely long roads. So these cars are numbered from 0 to n minus 1. So technically 0 in this array from left to right. So each car is present at a unit point. So we're given a 0 index string direction of launch and array. Okay, and then direction of the index can be either left, right, or stay. You know whether like index of each array car is moving towards the left, toward the right, or staying in the current point respectively. So each moving car has the same speed. So that means every car is going with the same momentum. The number of collision can calculate as below. So when the two cars is moving in the opposite direction, the collides can happen to each other. So if we have to go through like this, let's consider that we have one car in here. Let's draw the wheels. Alright, such a cute car. And then we have another car in here. Okay, I don't know why these are not coming along. Okay. So if two cars mean like one car is going to this way and another car is going to this way, that way cause a collision and that way. So when the two cars move in opposite direction collide each other, the number of collisions is increased by 2 since two cars is stuck in here, so that means the collision count is increased by 2. So when a moving car collides with a stationary car, and let's consider like this guy is stopping in here and then this guy is trying to go to the right. So that is going to increase the collision increase by 1. So after the collision, the car involved can no longer move. So if the collision happen, these two cars are totally stuck in here. So they're gonna move either way, according to the question, not in the real world. And yeah, we're also gonna change the state or direction of the motion. So we have to return the total number of collision that will happen on the road. So they just want to know like how many collision could happen on a given direction of the each car. Okay, let's run through the one assignment. Let's consider that we are given like right, left, right, stay, left, left. So to go through this, oh my god, why is this getting so difficult to use? Alright. Okay, we have this guy is going to the right and this guy is going to the left. So that's going to cause a collision by 2. Okay, so that is the first condition we are having in here. So this guy is going to the right and this guy is staying. So we are having collision by 1. So these both cars are stand. If this car going to the left, so it will cause the collision again. So one more collision. So this one go to the left. So cause one more collision. So 2 plus 3 will be to the 5. So that is how we get the 5s in here. So for the next one, that is pretty straightforward. Since each guy is going to the different direction, left, left, right, right. So there will be no collision. I think that's pretty much of it. I can directly imagine this is a stack problem. Let's check it is a stack problem after all. Yeah, absolutely. How can we count that? Okay, not the car. Let's go like let's cars will be the direction of the array. And we're gonna need to calculate like using the 2 pointers to save the performance in here. Okay, for the cars, I'm going to call like cars.count minus 1. That is the last index of the array. And then I'm going to ignore the car moving left at the beginning. So to calculate that, let's call like if the last index is less than or equal to the right. That is a universal truth for the 2 pointers. And then the cars from the left is equal to the L. That means like the first car is equal to the left. It's going to the left side. So we can increment the left by 1. So we are counting the direction for find the collision. So next will be the right. We can just copy and paste this. So that is a quite similar approach. That will be the right, and then it's going to be the R. So if like that, what we're going to do in here is we need to detect the one from the right. Since we are having an index on the top right side, and then we are gradually moving from the right to left for the right pointer. Okay, how about just return 0 and let me show the values of left and right in here. Let's call like left, right. Let's try to run it. So that will be the left is 0. Since we saw the first item is right, is index 0 is right. So we're not doing anything here. For the right, we are calculating, originally calculating as okay. So since we don't see the right also, so the index will be 0, 1, 2, 3, 4, 5. That's why it's stuck in here. So both are at the initial state and we're not moving anywhere. So if you go to the case 2, left will be calculated as like 1 and 2. Because we have originally 0 and we plus 1 for here, plus 2 for here. So begin the 2. For the right, we're going to detect like 0, 1, 2, 3. And then detect 1 and 2. So 3 minus 2 became the 1. So that is how we get the left and right. So next step is pretty straightforward. We will calculate like if left is stay less than or equal to the right, we're going to enter to the iteration like from index in left dot 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 right. So we're going to go from left to right, and then we are only going to calculate like cast of index is not equal to the S. That means like each card is not staying. That will be our reset. We need one variable called reset in here. And then I am going to plus 1 the reset in here and then just return the reset. Yep. Oh wait, what did I do wrong? Reset? Wait, I'm doing the correct thing. Oh, it's a plus equal to. My bad. Yep, that is pretty much of it. Let's try to submit it. I think for this one, the time complexity will be the O of n, the speed complexity will be the O of n also. But I think I can do the better performance in here by making the speed complexity to the O of 1. Since we are using the approach like a stack, there is one thing in Swift called trim prefix. Let's call like trimming prefix. That will be the parameter of first item is equal to the left. So technically we are trying to check how many left index in here. The same, we're going to do the suffix for the right. Yeah, that's what I was thinking. And then for the last, we are going to count the remaining array with the items is not equal to 0, same as the previous approach. And then just trying to run it. So that will be the O of n for the time complexity when, O of 1 for the space complexity. Unfortunately, I don't have a Leetcode premium, so I cannot see it. So I'm pretty sure that is O of n for the time complexity and O of 1 for the space complexity. Yeah, that's pretty much for it. And then see you in the next one. Bye.